In the last tutorial, I began to explain how you would solve a system of n linear equations using matrix inversion. We arrived at the result that we needed to determine the inverse of matrix G, this 3 by 3, in order to find the unknowns v1, v2, v3. If we could find the inverse of G, then the problem was pretty simple. So what we want to pick up with now is to consider how one would calculate the inverse of a matrix. So here is G, the matrix that we want to invert. And in order to give you the formula, I guess, we need to define some terms. So we can have a minor. We'll define a minor. First off, we can say rows and columns ID'd by I and j index. Okay, so we'll say that a sub ij is the ith row and jth column entry in G. So for instance, A22 is equal to 4 right here, and A31 is equal to 0, this one right here. Okay, now we can define a minor. Let's define a minor. A minor Mij, so this is the Mijth minor of a matrix G. And how do we formulate that? Here's the matrix G, and what we do is we cross out. Let's say we want to look at the M11 minor. We cross out the ith row, so that's 1 in this case, and we cross out the ith or the jth column. That's 1 in this case because I'm going after M11. And what I'm left with is a matrix of order that is 1 less than the original one. So this is a 2 by 2. And the minor is the determinant of what remains. Okay, so in this case, the minor is going to be the determinant of 4, 0, 0, 1. Oops. The determinant, so this is determinant. And if you need to know how to take the determinant, I have a separate video for that. But for a 2 by 2, it's very easy. It is 4 times 1 minus 0 times 0. Okay, so you multiply from top left to bottom right, minus top right times bottom left. So the determinant is 4, and therefore the minor 1, 1 of matrix G is 4. So let's try another one. Let's say we have M2. Let's try M1, 2. Okay. Now in this case, it will be, we'll cross out the first row, but the second column. And so we're left with 2, 0, 0, 1. And so that's going to be 2 times 1 minus 0 times 0, or in other words, 2. All right, and then let's calculate one more. M13. And in that case, this case, we're going to cross out row 1, column 3, and we are left with this 2400, and its determinant is 2 times 0 minus 4 times 0, so it is equal to 0. Now let's define another term, and that is, I'm going to move this over here. Equal 1. Okay, the term we're going to define now is cofactor. The cofactor. And I'll say Cij of matrix G. All right, and let's consider well, I'll just tell you what it is. Cij, okay, oops, is defined as -1 raised to the power I plus j times the minor ij. Okay, so it's very similar to the minor, but it is going to be multiplied either by +1 or -1, depending on whether I plus j is odd or even. Okay, and so we have the cofactor matrix. Okay, cofactor, let me write this way, the cofactor matrix, or cofactor of G, of matrix G, is, and I'll use bold C, is equal to a matrix that's the same order, 3 by 3, but with each entry being the corresponding cofactor term. C23. C31, C32, C33, where these entries are evaluated using this definition here. Okay? So we're almost at the point where I can define what the inverse of G is. In fact, I can write it out now. The inverse of G is, G inverse is equal to the cofactor matrix transposed, and I'll mention what that is in a minute, divided by the determinant of G. Okay, so a lot of arithmetic. So this is transpose. So let me show you that very quickly. Transpose is as follows. So let's say transpose of G, just as an example. So here's G. Transpose of G, we put a T up at the top right. And what we basically are going to do is just swap the elements along the major diagonal remain unchanged, and that's like the axis of symmetry. And then we're going to swap elements that are in corresponding positions as reflected across the that major diagonal. In this case, it's pretty trivial because we have a lot of zeros. But let me go ahead and write it. It's going to be 1 and 4 and 1 down the diagonal. And then the 2 and the 3 are going to flip, and then we have zeros in the rest of the entry, so there's not much else that happens. So this is the transpose of G. And what we need to do up here is to determine the inverse, we need the transpose of the cofactor matrix. Okay, so what's involved in taking the inverse? Well, you have to determine the cofactor. We have to calculate all the minors. There'll be 9 of them in this case for 3 by 3, and then you would multiply by -1 to the power of I plus j for each of those minors to determine the cofactor terms. You'd then form the cofactor matrix. Then you would take the transpose of that cofactor matrix and you divide it by the determinant of G. And I think in another example I'll actually work this problem out.